दिस वन इज फॉर द पैरेलल, दिस वन इज फॉर द पैरेलल, ठीक है। सो फॉर द सीरीज एज वेल एज पैरेलल वी हैव बोथ थिंग, ठीक है। सो बढ़ते हैं अपने नेक्स्ट न्यूमेरिकल की तरफ और देखते हैं क्या होगा। सो आई होप यहाँ तक बात समझ में आ गई होगी कि सीरीज ऑफ पैरेलल रेजोनेंस और ये सारी चीजें जो मैंने आपको जब थ्योरी पढ़ाई थी तो समझाई भी थी। अगर आपको डायरेक्ट याद है तो बहुत अच्छा, अदरवाइज यू कैन प्रूव। तो देखते हैं अपना नेक्स्ट न्यूमेरिकल। नेक्स्ट न्यूमेरिकल देखते हैं अपना। सो नेक्स्ट न्यूमेरिकल है हमारा इन द सीरीज रेजोनेंस सर्किट, इन द सीरीज resonant in the series resonant circuit, the impedance at half power frequency is okay, then ऑप्शन है हमारे 2r और नेक्स्ट ऑप्शन जो है हमारा r/√2 एंड सी ऑप्शन जो है हमारा है √2r एंड डी ऑप्शन जो है हमारा है r/2। देखते हैं क्या होगा। सो द in the series resonant circuit the impedance at the half power frequency. Now if you remember your resonance curve, then it is your omega naught, this one your omega 1 and this is your omega. I told you that at resonance at half power frequency z is equals to √2r. Here also z equals to √2r, but at resonance z equals to r, ठीक है यहाँ तक। now if you remember when your frequency is less than in this, then it is a capacitive region, it is your capacitive region and it is your what, inductive region and it is what, resistive region, exactly the resistive region. So in that, now if you more precise, then you have z is equals to √2 angle minus 45 degree because here the capacitive region, here the z is equals to √2r angle plus 45 degree, but here z equals to r angle 0 degree. तो चेक कर लीजिए कौन से ऑप्शन सही है। In the series resonant circuit the impedance at half power is what, it is √2r, sorry it is r is misprint, it is r √2r, ठीक है। सो ये ऑप्शन आपका बिल्कुल सही होगा, क्लियर है। एंड अगर पावर फैक्टर के बारे में पूछा जाए देन cos 45 एंड cos 45 इज 0.707, नेचर पूछा जाए तो लीडिंग और यहाँ कैसा हो जाएगा, लैगिंग, ठीक है। यहाँ तक आगे देखते हैं नेक्स्ट न्यूमेरिकल। सो नेक्स्ट न्यूमेरिकल है हमारा a circuit with a resistor, a circuit with a resistor, and inductor and a capacitor in series, okay, is resonant at f naught hertz if all the component if all the component values are, if all the component values are now doubled, the new resonant frequency, the new resonant frequency, the new resonant frequency is, ठीक है यहां तक ना। ऑप्शन है हमारे, फर्स्ट ऑप्शन जो है f0/4 है, बी जो ऑप्शन है हमारा है 2f0, सी ऑप्शन जो है हमारा, चेंज द मार्कर, now C option is f0 only, it is only f0, and D option is f0/2. Okay, so let's see what is the answer of this question. So a circuit with a resistor, inductor and a capacitor in series, the resonant frequency is f0. Okay, if all the components are double, then what is the resonant frequency? देखते हैं इसका solution now. So at series resonance, XL is equals to XC at omega naught equals to omega naught, at omega equals to omega naught. So we have omega naught L is equals to 1 upon omega naught C. So omega square LC equals to 1, or omega naught equals to 1 by LC. This is in radian per second. Now similarly, f0 is equals to what? 1 upon 2 pi 1 upon root LC. So this is in hertz. ठीक है यहाँ तक। अब हमसे ये कहा जा रहा है कि सारे कंपोनेंट क्या हो रहे हैं, डबल हो रहे हैं। तो अगर हम बात करें, your f0 is inversely proportional to L and C because it is independent of resistance. If you change resistance, then it has no effect on resonant frequency. Now see the formula, it is f2 upon f1, f2 upon f1 is equal to, I can write it is f2 upon f1 because it is inverse na. So let's take what it is, let's see, f2 is equals to 1 upon L2 C2. okay, इसी में अगर हम देखते हैं डबल कर देते हैं तो ज्यादा बेहतर रहेगा। ठीक है, सो अगर हम यहाँ पे देखें डबल करते हैं, then f0 is what, 1 upon, it is 2L and it is 2C. okay, so then we have 4LC. now 4 is coming out, so f0 is, it is just taking dash. okay, so it is what, 1 upon 2 outside, and it is LC. Now what is the 1 by LC, and 1 by LC is now f0, so f dash is f0 by 2. So when your component becomes double, your frequency becomes half. okay, so what is the answer? So we have D option correct. So the option D is correct. okay, now let's see the next question. So देखते हैं हमारा नेक्स्ट क्वेश्चन क्या है। Now our next question is, if in an RLC series circuit, the frequency is below the resonant frequency, then ऑप्शन है आपके XC इज ग्रेटर देन XL। बी ऑप्शन जो है आपका है नन ऑफ दीज, नन ऑफ दीज। और हमारा नेक्स्ट ऑप्शन जो है वो है XL इक्वल्स टू XC, और जो डी ऑप्शन है XC इज लेस देन XL। ठीक है, ये रहे आपके चारों ऑप्शन। देखते हैं क्या होगा इसका सॉल्यूशन। So if in an RLC circuit the frequency is below the resonant frequency, now if you see XL is omega L, so XL is directly proportional to omega. Okay. Similarly, if you see XC is what? 1 upon omega C. Then it is inversely proportional to omega. Now frequency is below the resonant frequency. If your frequency is below the resonant frequency, then it is low. When it is low, it is XL is low. Now when frequency is low, it is high. So for low frequency, for the frequency less than the resonant frequency, your XC should be greater than XL, and that region is capacitive and power factor should be leading. What is the option? XC is greater than XL. Okay, so this is your condition when this is the correct one now. So if F is less than F naught, and this one is at F equals to F naught, and this one is when F is greater than F naught. Okay, so what we have A option according to your question. Next देखते हैं क्या question होगा. Now in an parallel RLC circuit, in a parallel RLC circuit, in a parallel RLC circuit, if the lower cut off frequency is 24000 hertz. Okay, and the upper cut off frequency is 28000 hertz. What is the bandwidth? What is the bandwidth? What is the bandwidth? Okay, now option है हमारे, पहला जो ऑप्शन है वो है 5200 हर्ट्ज, अगला जो ऑप्शन है हमारा 2400 हर्ट्ज, और सी ऑप्शन जो है हमारा है 2800 हर्ट्ज, और लास्ट जो ऑप्शन है वो है हमारा 400 हर्ट्ज, that is 400 hertz. So let's see what is the question answer. Now in parallel RLC circuit, if the lower cutoff frequency is 2400 hertz and the upper cutoff frequency is 2800 hertz, then what is the bandwidth? Now if you remember your bandwidth curve for the parallel resonance, I just draw the resonance curve for the parallel circuit. For the parallel circuit, if you see this curve, it is your resonance point, and I'm just taking same value. It is what? F1 and F2. Okay, so it is called lower cutoff frequency as well as low power half frequency, या half power frequency. ठीक है, similarly it is called upper cutoff frequency और इसको हम बोलते हैं अपर कट ऑफ फ्रीक्वेंसी एंड इट इज कॉल्ड हाई पावर frequency. High power frequency. Okay. So if you see from the curve, the bandwidth is what? Difference of these two. Bandwidth is difference of these two. Then bandwidth is f2 minus f1. Now how much is your f? F is highest 28,000, 2800. Sorry. And what is the f1? Is the lower cutoff 24,000. Now what is the difference? It is 400 hertz. So this is your bandwidth. Okay. So we have D option correct here. Okay. D option is correct. Now next see the next question. I hope so ये बात समझ में आ गई होगी. Now see the next question. So let's see the next question. Your next question is, in RLC circuit, the electric current in RLC circuit, the electric current, in RLC circuit, the electric current at resonance is, ठीक है यहाँ तक. और आपके ऑप्शन है, पहला जो ऑप्शन है वो है, देखिए क्या है, maximum in series circuit, and minimum in parallel circuit, ठीक है यहाँ तक. ये रहा आपका पहला ऑप्शन. बी ऑप्शन जो है आपका है maximum in parallel circuit, and minimum in series circuit, in series circuit. सी ऑप्शन है मैक्सिमम इन बोथ सर्किट, मैक्सिमम इन बोथ सर्किट, एंड द लास्ट ऑप्शन इज मिनिमम इन बोथ सर्किट, मिनिमम इन बोथ the circuit. Okay, ठीक है यहाँ तक. So this is your question. Now in an RLC circuit, the electric current at resonance is. Now if you remember, either you can take option from the curve, or you can just try, or you can have the knowledge of these two from your lecture. Okay, so let's see first. In series, it is the JXL minus XC. So this is 0. Okay. So your ZT is R, is minimum, if you remember. Then your I is what? V upon Z, that is minimum. Then its current is maximum. Okay. So this is about the series. This is about what? Series case. Now similarly, if you have parallel circuit, then imaginary part is 0. Then imaginary part is 0, then Y is what? G, and it is minimum. Okay, but the Z is what? V upon I. Sorry, yes, Z is what? 1 upon Y, and Y is minimum, then Z is maximum. Now apply for the current, then apply for the current. I is what? V upon Z, and Z is maximum, then current is what? Minimum. Okay, so let's pick the answer. In series circuit, the current is maximum, and in parallel circuit, the current is minimum. So in series circuit, your current is maximum, then in parallel circuit, your current is minimum. Now, in maximum, in series circuit, the current is maximum. That's why it is called acceptor circuit. It is called acceptor circuit. Okay. Similarly, for the parallel circuit, your current is minimum. That's why it is called rejector circuit. Okay, it is called rejector circuit. Done. So let's start the next point. Now, if you draw the curve, then from the curve, it is current is maximum, and for parallel resonance, it is also minimum. So from both, you can pick your answer. So लेते हैं अपना नेक्स्ट न्यूमेरिकल, एंड इस क्वेश्चन के लिए जो हमारा आंसर सही होगा वो होगा ए करेक्ट. ठीक है, तो लेते हैं नेक्स्ट क्वेश्चन, देखते हैं क्या होगा नेक्स्ट क्वेश्चन. सो लेते हैं अपना नेक्स्ट न्यूमेरिकल. So our next question for a resonance circuit is the electric current. The electric current in an RLC series circuit at resonance is. So पहला ऑप्शन जो है हमारा है इट इज मैक्सिमम, एंड नेक्स्ट ऑप्शन जो है हमारा वो है मिनिमम, और सी ऑप्शन जो है फिर इंफिनिटी, और डी ऑप्शन जो है हमारा है जीरो. सो इस क्वेश्चन को हम बहुत बार सॉल्व कर चुके हैं. द इलेक्ट्रिक करंट इन एन RLC series circuit at resonance is. So you remember I is equals to V upon Z, and in a series circuit your impedance is minimum, then your current is maximum. Clear है यहाँ तक? So for this question we have again your answer number A is correct. Okay, so answer number A is correct for this. Now see the next question. Now next question is at a frequency less than less than the resonant frequency. फर्स्ट ऑप्शन है आपका सीरीज सर्किट is capacitive, and parallel circuit is inductive, and parallel circuit is inductive. This is the first option. And the next option, series circuit is inductive, and parallel circuit is capacitive, and parallel circuit is capacitive. ओके। सी ऑप्शन जो है आपका वो है both circuit are इंडक्टिव। ठीक है यहां तक। और हमारा जो डी ऑप्शन है बोथ सर्किट आर कैपेसिटिव, बोथ सर्किट आर कैपेसिटिव।